What's up for September? Moving fast in the cosmos with planet Mercury and stars Arcturus and Altair. You'll have to be quick to catch a glimpse of Mercury this month, as the innermost and fastest moving planet, namesake of the fleet-footed mythological messenger, appears low in the west for a short time following sunset. But those with a clear view toward the horizon will be rewarded with some nice planetary groupings for the first week and a half of September. You'll find Mercury just a few degrees above the western horizon about half an hour after the sun sets, with much brighter Venus higher and slightly farther to the south. On the 9th and 10th, look for the pair to be joined by the crescent moon. In between the two planets is the bright star, Spica, which is actually two stars orbiting each other at a distance 3 times closer than Mercury orbits our sun. Mercury should be visible for you from the mid-northern latitudes on south. The farther south you are, the longer Mercury will be above the horizon for you before it sets. In addition to Spica, 2 other bright stars you can easily spot early in the evening in September are Arcturus and Altair. Arcturus is the brightest star in the northern sky. It owes this status largely to the fact that it's relatively close by, at about 37 light-years from our solar system. You can find Arcturus in the west in the first couple of hours after it gets dark. Look for the Big Dipper and follow its handle over toward the south about the width of an outstretched hand. It's easy to remember with the phrase arc to Arcturus. One interesting thing about Arcturus is that compared to other stars, it's moving extremely fast with respect to our solar system. In fact, the discovery of the star's motion was a huge moment in astronomy. Before that, the positions of the stars were thought to be fixed and unchanging. After Edmund Halley's discovery, the understanding that the stars move around as independent objects began to take hold. After you've found orange-colored Arcturus, spin yourself around toward the south-southeast to find Altair. You'll spy it hanging right above Saturn all month. In fact, it's about as high above Saturn as Saturn is from the horizon. Altair is a bright, white-colored star, which makes for a nice color comparison with Arcturus and nearby Antares. At just 17 light-years away, it's definitely one of the closest bright stars to our solar system. One of the coolest things about Altair is that it rotates so fast that it's flattened into an oval shape. Since it's so close by, astronomers have actually been able to image this fast spinner's flattened shape directly. So look for Altair and Arcturus in the September sky, 2 bright, nearby stars that, along with Mercury, each have their own spin on what it means to be fast. Here are the phases of the moon for September. You can catch up on all of NASA's missions to explore the solar system and beyond at nasa.gov. I'm Preston Dykes from NASA's Jet Propulsion Laboratory, and that's what's up for this month.
NISAR is a satellite mission that is going to be observing the Earth with radar. It will have 2 radars that view the Earth at different wavelengths. We can combine those data that allow us to learn more about things like vegetation and soil moisture than we can do with only one of those wavelengths.
So NISAR is definitely going to be a breakthrough for field-scale soil moisture, which is one of your main drivers of both food security and then as well more on the economic commodity forecasts.
NISAR is going to look at objects that's the size of about 60 meters in size, which is typical soccer field, to about 200 meters. We'll be able to see whether a particular patch of that size is wet or dry.
The current land surface models can't really quantify irrigation, so NISAR is going to now help understand how much water is actually being used to grow a crop, which will help us save water, so that's kind of a big deal.
See the middle there? The middle is set though. I think we just need to bend the edges.
We're going to deploy a couple dozen of these reflectors. Each one of these reflectors has to be the same brightness, and that tells us how we have to calibrate the image and so that we can use it for science. And no matter where we put them in Oklahoma, we want them to have the same brightness in the radar image. The science team is working with a lot of agricultural scientists, with the USDA and other agencies, and trying to make sure that the products from NISAR are useful, make sure they understand the soil moisture conditions and where crops are being grown.
understanding the moisture in the soil can definitely help those farmers better understand what's happening underneath the ground. Do they need to water? Is there too much water there? They just need to kind of let things grow. You know, are they in a drought condition? If they do need to irrigate, how much? All those different things just to better help those farmers make the best possible decisions for their crops.
We have a lot of rainfall and vegetation with flooding, extreme temperatures. You get all this production of vegetation and then you get drought and it dries it out. All of these extremes, we need to know more about the climate and what is happening with soil moisture. And I'm hoping that the NISAR data can help agriculture and learn more about what's going on in the ground beneath them to help with production.
I truly believe that agriculture is one of the kind of central components to many what we call sustainable development goals. Poverty, nutrition, livelihoods, environment, whether it's water, soil, air, to lift people out of poverty. So it's something I personally believe in philosophically and hope to spread the wealth.